two major concepts are there in week 9, which is recursion, and second is DFS, depth first search. So today's whatever questions which we are going to see, as part of this solve with us session are based on DFS and recursion. All right. So we will start in that manner. I hope your quiz 2 went well and there wasn't a big concern regarding that. We will be announcing the results soon. As you know, it takes for at least a week or week and a half to process your scores and release them. So be patient. We'll release them. Without waiting further, let me start the session and I will share the joining code for the peer deck with you.
Yes, sir.
So sorry to interrupt you. You said that it will take almost a week to declare the results for quiz 2. Is that
usually it takes week, at least a week or so. The exams happen on Sunday, right? We are processing your results. We'll try to announce them as soon as possible. But as I said, it takes some time.
Yeah, thank you. Thank you.
Yeah. All right. So just hold on. I'm posting the code to join this particular peer deck. So you have to go to joinpd.com and enter this code in order to join the session. Yes, is everybody there? Have you joined the session?
Yes, sir.
Yes, sir.
All right. So, but still, for the safer side, let me quickly keep it shared so that.
Actually, sir, I have lots of background noise, so I can't speak to this.
Yeah, that is fine. That is fine. Please keep yourself on mute. It's too loud. All right. So anyway, even though if you're not there, I have shared my screen, but it's better if you join the peer deck. Otherwise, you will not be able to give answers from there. All right.
Yeah, I will join.
Yeah, sure. So as you can see on the right corner, this particular code is available, and also I have posted in the chat, so you can pick it up from there. So let's start with first question for this week 9 solve with the session. Okay, so the first problem is given a list of integers sorted in ascending order, write a recursive procedure that returns the list sorted in descending order. So what is given to you? A list L is given to you, which is in an ascending order sorted manner. Okay. And what you're supposed to do is you're supposed to convert that list into a descending order sorted list. Okay. So that L, whatever L is there, you are supposed to reverse it, right? So if length is less than or equal to 1, you are simply returning L as it is, right? That's but obvious. But if that's not the case, then what should be the code? So that's the code you have to fill in over here. And as you will see on your peer deck side that there will be 4 options given. So I give you, let's say 2 minutes. Submit your answers. Is there any doubt with this question? If that's the case, please ask me.
No, sir.
Not
No,
done.
sir.
Okay, okay, Sapna. Yash, Sridhar, do you have any question?
No, sir. I'm done, sir.
Okay, no, you are on unmute, so I thought you might have a question.
Done, sir.
Okay. Yeah, I can see from my end. But
It's peerdeck.com only. Na? I don't know. Today I'm unable to join.
no, it's joinpd.com.
Sorry, I forgot.
Okay, so various responses are coming right now. I'm seeing something around 15, 17 people have submitted. But in this meeting, there are 50 plus participants. So let's wait for a few more responses.
Sir, we have 125 slides today.
No, don't worry.
Okay.
Don't worry about that number. It's based on graphs, right?
Okay.
So
Okay.
that's
I
why
thought-
the number of slides are that high.
I thought, sir, it includes the solution also. So that's why
Yes,
it is
yes.
too extended.
Yes, yes. It includes very detailed solution. That's why
Yeah,
it is
yeah.
like that. The session will be 2 hours. We'll finish it in 2 hours. Don't worry. Maybe 10-15 minutes here and there, but otherwise don't get bogged down with that number of 125.
Okay, sir.
Yeah. So 23 responses so far. Guys, come on, submit it. Only 32 have joined the peer deck. Rest, what's the problem? See, if you're here only for bonus marks, then maybe I will for bonus marks I will consider the attendance on peer decks rather than Zoom.
Sir, can you provide us the code once again, please?
It's okay. Can somebody post it in the chat?
Yeah, sir.
Yeah.
It's already in the chat.
Yeah, he might have joined late. So somebody can post it again?
Excuse me, sir.
Yeah.
Sir, your screen is not visible.
Yeah.
You shared or not?
No, I've stopped sharing because I am
Okay.
going through everyone's answer.
Okay.
So that's why I've stopped it. I'll share it again once before I start explaining it. Right now, I'm seeing the screen where I can see all your submitted responses. So I don't want to present that at this point of time.
So it means you are forcing the students to join PD.
Yeah, I mean, actually, this is something we discussed also internally, and that might come in as a formal thing here onwards.
Yeah,
See,
it's needed.
Yeah, it's needed. Exactly.
Needed. You are right.
Yeah. You can't just simply join the session and go to sleep and ask for bonus mark. You have to be here. You have to be active.
True.
Otherwise, it completely loses the purpose of bonus marks, right?
Of course, sir. Those who students are active, they deserves.
Exactly. So as I'm seeing on peer deck, only 39 are active, but on Zoom meeting there are 54. So some 50 plus number should be there on peer deck side, but that's not the case. So this time I am going to compare both the logs, the log from peer deck as well as log from Zoom. Then we'll see what to do about that margin between both these numbers.
Okay.
All right, last 30 seconds. 34 responses so far.
Sir, can you please tell me the password, please? Because I joined just recently, 2-3 minutes
Yeah,
before.
yeah. Somebody must have posted it just now. Can somebody post it? Yeah.
XLILEO.
Okay, okay, got it.
All right, so time up. Let's see what the answer is and why so. Right. Let's first see how many students have submitted what. Okay, so that's the submission. Can you see it now? I've shared my screen.
Yes,
Yes,
sir.
yes, sir.
Yeah, so I was looking at this, that's why I stopped sharing. Now there is no point in submitting, right? I mean, I have already saw what the numbers are, but yeah. So as you can see, the option B is the most popular option, but there are 4, 5, 6 people who have submitted other options. So let's see that what is the case and how the option B is right or whether it's wrong. Let's see what is happening. All right. So let's try to solve this question. And first, go back to actual code. So let's consider this example. The sorted list is 1, 2, 3, 4, 5. It's right now in ascending order sorted. We want to reverse it. So in order to reverse it, what is our first step should be? We should extract that 5 from the end and bring it
Yes.
at the beginning of the list, right?
Yes,
That
sir.
should be our
Yes, sir.
first
Yes, sir.
step. Okay.
Yeah.
So
Yes.
let's do that. How to do that? We
Last of
brought
L.
from 5 into first. So how we'll get that 5? That's the last of L, right?
Yes,
So
sir.
this is what we will keep doing. We'll bring something from end, append at the beginning, right? You bring something from the end, append, right?
Yes,
That's how
sir.
we will go. Now, how to do this using our list functions, right? Let's look at that part. Now, the blank pseudocode which we had, as you guys were talking, similarly, same thing. The last of L will give you this 5. And init will give you the remaining part of it, right? So somewhere we have to also update we also have to change that L in order to get that remaining 4 elements, right? Otherwise, every time last will keep giving us the same element, which is 5, 5, 5. That should not happen, right? We do not have any, when we say last of L, it doesn't actually remove element from there. It just gives us that element. But somehow we have to remove that element from the end also, which will be done by this init procedure, correct?
Yes.
So last will give us the last element and init will reduce the size of that list. So with the combination of these two, we should proceed further. So let's see what should be the correct combination of last and init in this case, right? So let's continue on this. So this init, as this init of L is 1, 2, 3, 4. Again, it's a sorted list, but the length is lesser. Earlier, the length was 5, but now we have length which is less than that. Apart from that, this is still a sorted list. So we can apply that same logic again on 1, 2, 3, 4. Extract 4, which will be used by last of L will give you 4, and init will give you just 1, 2, 3. Keep doing that again and again and again until we have only one element left in that list. And that is exactly what this DESC or the descending order procedure is doing. Because of that, we can call that particular procedure again, as we call it a recursive call, recursive procedure call, a recursive function call, where we are passing that init of L again, right? So this is that code is return last of L plus as in that list append operation, and the call of that procedure again, and that was the answer. So when we keep doing that, that's how our L will be created, right? Now, yeah. Any doubt? I mean, I will go run through the entire program and entire list one element at a time. That will do. But so don't worry about that. I mean, whatever I just spoke, it was just top level view or the general view of the particular question. Now we'll go iterate through it step by step. So that will do. Before that, is there any question?
No, sir.
Yeah,
No.
Please
and
go
that is
ahead.
and that is the reason number of slides are that high. Okay.
Yeah.
So as you can see, the green is the ongoing call of the procedure. I mean, I'm using these colors to simplify the explanation of it. So green represents what? It represents the current procedure call. And as we keep going ahead, we have to suspend the previous procedure call, then only we can start the new call. And the red, that's yellow color, and red represents the completed, as in the procedure call is completed for that particular procedure call. Okay, that's how it goes. So first, as we start, for example, as we taken the example of this 1, 2, 3, 4, 5. So our first call to this procedure DSC will be like this. What happens after this? If length of L is less than equal to 1, in this case, length of L is 5. So that's not less than 1. So if will not execute, you go to return. Guys, can you please keep yourself on mute unless you are talking? There is some noise. Yeah, thanks. So in this case, what happens? Return in bracket last of L. What last of L will give you? It will give you 5. 5 and then plus DSC of init. Init will give you 1, 2, 3, 4.
1, 2, 3, 4.
Yes, earlier. And for that sub list, right? It's a sub list, but still it is sorted. And for that list, we will call this same procedure again. How that will go? It will generate another procedure call with this, as you can see, the green colored one, DSC, where the parameter is 1, 2, 3, 4. That's how that procedure call will go. And as I was explaining, when we start a new procedure call, the previous procedure call gets suspended. It is not yet finished. In order to finish this previous function call, right? In order to finish this particular function call, this particular procedure call, we need a result of this part, DSC of init, right? Unless and until we get result of this particular procedure call, we cannot do this return statement. And that is why we have suspended that call and started a new call, right? And when we start that new call, as you can see on the left hand side, last of L gave you 5 plus a new call which we started, and that is what we will keep doing. Now let's suspend this call, and now same thing, last of this current call will give you 4 as last element, and init will give you 1, 2, 3, and with that 1, 2, 3 we will have another call, right? So as you can see on the left side over here, 5 plus 4 plus now the current call which is going on, which is with list 1, 2, 3. Similar process, we will extract 3 and do another call with 1, 2, 1, 1, 2. That's where we are at right now. Same process will continue, where last value is 2, and now list contains only one element, which is 1. Right? At this particular point of this particular execution, now list length is 1. So what we say, if length of L is less than equal to 1. Now this becomes true, right? Now length of list is 1. In that case, we will return L as it is. Now, what does that mean? Return L. What is L right now? L is just a list with one element inside it, which is 1. So now this particular thing, as you can see, DESC of 1, this will give you a concrete value. Right now it's a procedure call, but this particular thing will give a concrete value, which is just 1 inside a bracket, right? Like this. Right now, forget about color, but this is how it will be. 1 will be given to you, 1 will be returned. Now this operation we can do. Now we know what is the what we are supposed to do with this plus operator. We are supposed to append it one at a time, and that is when we will start completing these procedure calls. Earlier they all were suspended, right? They were on hold, they were waiting for something else to happen. Now that thing is completed. Now we can start closing them one after the other, and they will get closed in the reverse order in which they were generated. So generation happened from bottom to top. Now closing of the procedure call will happen from top to bottom. First we will close this. So that the red color one, as you can see, and that gave us this red color one. Now we can append 2 and 1 together, right? So let's do that.
This part is not clear for me. Sorry to interrupt you. This part is not clear for me. I'm not able to understand this.
What part?
This is okay till 1 is there, but how 5, 4, 3, 2 are appended to the list 1?
They are not appended. See, that is what I was talking about. We started from here, right?
No,
When
till last time clear. In
No.
it, L1 is came.
Correct.
There
See,
I'm clear.
this 5 was already there.
But we are suspending that call, right?
Yes, suspending, that is fine. But that call somewhere that is there, right? We extract that last L. Last L gave you 5.
Yes, yes. But
And
where
then
it's storing?
then we
Is
did
it
the
storing
procedure call.
somewhere? Is it
Yeah,
storing
yeah. So,
somewhere?
yes, see, that is what I mean. I did not wanted to go into details of how operating system do it internally.
Actually, after watching the video also, this part is not clear for me. Where it's storing 5, 4, 3, 2.
Yes. So let me tell you how actually it works. Okay. This is something which is very trivial with respect to operating system, but it doesn't have that much. I mean, it's not important for computational thinking course, but to give you a general perspective on how it works. Okay. So if you understand it, it's good. If not, you can ignore it. You don't. No question will come in this course based on. Okay, this is just to give you some extra knowledge. So the thing is, not just for you, for everyone. Yeah.
I just want to add here. It's a kind of stack is being maintained.
Yes,
here.
Ram. Yes,
as we can see here, the stack of calling.
Correct. So what Ram is saying is correct. There is some concept called as stack. It might be too technical term, but let me explain it in easy manner. What happens is, every time when in a procedure or when a pseudocode runs, we have variables which store various things, right? We have variables to store it. But in a computer system, those variables are stored somewhere, right? For us, it's a variable, but computer is a hardware machine. It stores those variables in its own way. And all those variables are stored in something called a stack. It goes into a memory. It goes in the primary memory, which is generally RAM. You must have heard the word RAM, right?
Yes.
Random access memory. So that's the place where something called a stack. It's a proper data structure which you will study in detail in upcoming courses. But it's just a data structure. It's the way to store data.
Is it a temporary storage?
Yes, it is a temporary storage. See, anything which gets stored on RAM, it's temporary. As soon
Okay.
as power goes off, RAM memory goes off. That's how it goes.
Excuse me, sir.
Yes.
So I lost my connection. So I rejoined that now. So will you please explain what you said earlier? I
See, I
got
can't
the
repeat
stack.
everything again. I'm explaining that part only. So
I
the
got
thing
the
is,
stack. What did you say that I got it because I know how stack works.
okay.
Before that, what did you said?
Yeah, okay. So I'm continuing on that explanation. Yes,
Okay,
on
okay.
stack, these values are stored. So this 5 got stored when, see, someone has to keep track of all this, right? The which call, now we made this call. Till here it's fine. But when this call got suspended and when this call is ongoing,
Yes.
somewhere computer have to keep track of this. And this all this process is done by that stack data structure. So that stack data structure maintains the current whatever value which is computed so far and the ongoing procedure call. So this is the stack. I mean, what is stack? When you, I mean, it's simple stack as in the pile of cards what we have. When you put something, store something on top of each other, right? When you, as we call it, stack of books. When you have one book on top of other, there is another book on
Yes.
top of that. That simply stack. So whichever, and that is why, as I said, this right color, this colored one, right, yellow green thing, as
Yes,
you can
yes.
see, every time a new call is made, it is on top of the old one.
Okay.
That's how stack grows, right? You cannot insert something in between stack. It's always at the top of the stack, right? When, I mean, you have maybe kept 10 books, if you get 11th book, you will keep on top of that 10th book, right? That's the most natural thing to do, right? You can of course insert it in between, but with respect to stack, the general principle is you put whatever is at the top, and whenever you want to remove, you also remove from the top. That's the natural process with it. And that's why
Yes, sir.
every time a new call gets it adds another call at the top of it. And now we are going to start closing those calls. I think we'll start completing those calls. Now again, completing process will go from top to bottom, right? Because we do not have access to, I mean, it's very tough, no? I mean, even in practical, if you are supposed to extract a book from the bottom, it's tricky. But the picking a book from the top, it's the easiest one. So that's most natural way to do it, and that's how the
So it
stacks
means
work.
we are here no need to write anything related to stack up for the computer. It will do on its own.
Yes, that
This
is operating
program?
system's job to take care of it. Even when even if you write this code in any programming language, right? Any proper programming language instead of pseudocode in C, C++, Java, Python, .NET, anything.
In
It's an
DSA,
operating
na?
system. Yeah, it's operating system's job to take care of this stack business. We don't have to write any code for
Yeah,
that.
that is actually part of the return function itself, right? To make it until unless everything suspended, it will keep the data which is temporarily stored with the return value. Yeah, that is part
Correct.
of the return function itself.
Yes, so it is taken care by a combination of operating system and something called as compiler who actually process these codes, right?
Okay.
So
I'm
that is
very new
something.
to the programming. I'm new
Yeah,
to
I
the
understand.
programming.
I
That's
understand.
what.
So simply as a programmer, you don't have to worry about it. Okay.
Okay, fine.
Yeah. So now the process of closing these or the completing these calls started now. So we closed the first one. So now 2 and 1 got appended, as you can see over here, right? 2 and 1 got appended.
Sir,
Now the
it is
same,
just like,
yeah.
sir, it is just like, na, like first in, last out.
Yes, correct. No, first in, last out is different. This is first in, first in, last out. Correct.
Yeah,
Stack is
yeah.
first in, last out.
In queue, first in, first out, right, sir?
Yes, correct.
Yeah.
Yeah, whatever you are saying is correct, but that is irrelevant for computational thinking. That is something we
Yeah.
will study in
Yeah.
other course called PDSA.
Sir,
Yeah, DSA.
DSA, yeah.
sir, isn't this last in, first out stack? What goes in last?
Whatever it is same. Like
Yeah, it's same.
last in, first out, and first in, last out. It is same.
It is same. Okay. See, the point is, see, this is the procedure call at the bottom. We started this first, right? And when we will close this at last. So first in, last out. That's how it goes. Or on the contrary, This is the procedure call, the previous one, this one, DSC of 1. It came in last, but we will close this one first.
Right.
So you can see it either ways, both holds true. Okay.
Before.
Yeah. So let me, and don't worry about these terminologies. Okay. First in, last out, last in, first out. Don't worry. Nobody will ask you about this in computational thinking.
So this stack up, what you explained, really very good. I understood. In detail,
Okay.
I understood how this process is going on stack up.
Okay.
Sir, effectively in the procedure, L is getting replaced by init of L in each recursive procedure.
Yes, correct. Absolutely correct.
So means so in the fifth one, it will be like init of init of init of init of L, something like that.
Yes, exactly. Exactly. That's what it is.
So the answer is B.
Sorry.
The answer is B, right?
Yeah, answer. Let's see, right? Wait for that. Why do you want to run to the end? Let's go there step by step, and together let's see what the answer is, right? So right now we just close these two. Now we are supposed to close this third one, and it's semi-straightforward. One by one we will keep closing the procedure calls, and as we keep going we will append that list. Now we have the final list in a descending order: 5, 4, 3, 2, 1. All procedure calls are closed. Now this is actual return value, which this particular return statement will return back, right? And as you can see, this is this worked, right? Nothing went wrong. We got our actual answer. So this is the answer, and this was option number 2, right? I don't remember the option sequence.
Yes.
But I think this was option B. Option B. Yes. Any doubts so far?
No, sir.
No. Somebody.
Still clear, sir.
Yeah, Ramakan.
Sir, actually here we made this because we had 1, 2, 3, 4, 5, and then only we write this last of L. Then we did appending the last element first. Then subsequently the rest of the things follow. So
Correct.
is it like a common method to making an ascending order?
No, it was given, right? It was part of the question. The original list given to you is in ascending order. Can you read the original problem statement? It was given. That's why it worked. Otherwise, it will not work, right? If your input is not in ascending order, then this code will not work. The given list of integers sorted in ascending order. It is given to us. I mean, it is assumed that it is in ascending order. Then only this code will execute. Otherwise, you will have to do the proper insertion sort, right? You will have to execute entire insertion sort.
You will have to sort the list first.
Correct. Then the sorting has to happen first. And in that case, why to do this procedure? You can sort itself in descending order directly, right?
Yes, here sir. It is already sorted.
Yeah, here it is already sorted, but not in the way we want. We want in descending order, but it is sorted in ascending order. So we simply reversing the order. That's all. We are not sorting. We are reversing the order.
Sir, I have a question.
Ramakant, is that clear?
Yes, sir. Sir, one more follow-up. Like when we are returning L alone, how that value is getting appended directly? Because in the return one that I got clear, the last of L, then plus we are making that is getting appended. But in the when it is at the last stage, when length of L is equal to 1, that is I do have the last element. That time it is L. So only that value is coming, or it is because we're not putting any plus sign there. So how it is getting appended? Just because it is the last one, so it is automatically getting appended?
No, it's not automatically appended. What our procedure says, last of L plus whatever is returned by this particular procedure. So the plus is we have written here, right?
So that is the L
yes,
part,
sir.
right? I'm saying the last one. Let us say everything completed till 1 to it's completed. That is very clear. The last stage, the descending one.
Correct. So over here, till here it is fine.
Yeah.
Now our call is what? DESC 1, 2.
Yes.
Correct. So with that, this will give you what? It will give you 2 plus DESC with call 1.
Yes. So
And
this
DSC of 1, DSC of 1 will return 1. The plus plus was already there. So it came from previous, it came from here. Okay.
Previous line is in that. Okay.
Got it, right?
Yes, sir. Yes. Sir.
Yeah.
Thank you,
Okay.
sir.
Yeah, thanks. Yes, Lakshmi.
Sir, if the list is not in ascending order, then
Mhm.
the resultant list will be in the reverse order of the list, right?
Yes, correct. If the original list is not in ascending order, it will be simply some list in a reverse order. We may not know what the order is. Correct.
Okay, sir. Thank you.
Yes, thanks. Okay, so if that is clear, can we move to second question?
Sir,
Yes, sir.
Yes, Dibakar.
yes. So can we quickly check why the last option will not yield the correct result?
Yeah,
here?
sure.
Because the last is not the least.
Because it's not a list.
List. Yes, sir.
Let me, I don't remember what the last option is. Let me go back to the question to see it. Okay, so last option is what? Okay, so only difference is this is not a list. In order to make this plus plus operator work, right? The plus plus operator would work only if there are lists on both sides.
Right. Okay.
Right, you understood, right? That's the only small, it's a subtle difference, but it's very important one.
Yes. Only confusion was between that second and last option.
Yeah. So it is correct. Only the brackets made the difference. The square brackets for last function made the difference. All right, then.
Okay.
Yeah. I don't know. Is there any way to jump to some next slide directly? Okay. So next, this is the question. I will quickly read it and explain you what it is, because there is a chance of slight confusion in this question if you assume something which is not there. So let me explain it a bit. So there is a robotic student who is designing a line following robot. Okay, this line following robot is very important. Okay, the bot as in the robot can either move one step left or one step right. That's it. It can do. Okay, it can go either left or right. There is no front or backward movement. Okay, it simply can keep going left right in that same line. That's the important part here. Okay, the sequence
Yes,
of
sir.
moves of the bot is recorded in a list called moves. For example, consider the following list. Moves is equal to left, right, right. So it first went one step left, then it came one step, then it moved one step right. So at this point, it again came to original position, right? You
Yes,
take one
sir.
step left and again one step right. That means you again came back to your original location. That is important. Okay. Then write a procedure that accepts the list of moves and returns true if the bot is at the same place where it started, and false otherwise. Okay. So this particular procedure will return true if bot came back to its original position, and if not, you will return false. Right. Now let me show you the pseudocodes. So this first you should read this pseudocode. This pseudocode talks about procedure each start moves the given input list, and if the numeric value is equal to 0, we return true, else we return false. Right? That's the original procedure, and in that procedure we are calling this numeric one, which is this second procedure. And in this second procedure has something happening inside, that's the actual logic of this question, which you have to figure out and submit the answer. And in this case, I have not given you any multiple choices. You have to type the code over there. So whatever the code it is supposed to come inside this, if this field code part, right? You are supposed to write it there. You have to type it. So I will give you maybe 2-3 minutes to submit the answers. So far, there is one response, as you can see, 1 out of 53 responses.
So can you please show the list?
You don't have to know the list, right? It's a generic pseudocode. You don't have, you're not supposed to write the code specific to that particular list. It's a generic code.
Okay, sir.
Fourteen, 15 responses so far.
Done, sir.
All right. Let's wait for a couple of minutes for others to figure it out. Let me see what you guys have submitted. So out of, am I audible, right? Yeah. So
Yes, sir.
So out of these responses, only 3-4 responses are correct. Okay, so 6 responses are correct so far. Okay, small hint, it's a one-line code. So I am seeing people are writing 5-10 lines of some lengthy codes. It's not required. It's a one-line code. That's why I asked you to type it. It's simply one return statement, nothing else. That's the hint for you. Think accordingly, and you can resubmit it. You just have to go there and edit your response again. Whatever you edit, it reflects on my end. So just go there and edit it again. You don't have to do anything different than that. So guys, just one quick warning that my I don't have electricity in my area since morning, and my laptop battery is running out. So I might get logged out, but don't exit the session. I have already informed Rahul will take it from here onwards. Okay.
Yes, sir.
So just
Okay.
yeah, in case if there is some few minutes gap in between me, my laptop shutting down and
Yeah.
him joining, just be patient. He will join. I've already informed, so he will take over the session.
Professor will be with us.
Yeah, sir.
Yeah. So in
No
meantime,
issues.
anyway, please continue submitting the answer for this question. As I have told, it's one line statement. It's a written statement. Think in that direction.
Sir.
Yes, Sapna.
Sir, how long this session is going?
It will be 2-hour session, just like any other, 2 to 4.
Okay. Okay.
I mean, it is expected to be 2 to 4, but it's something. I mean, sometimes discussion goes beyond 2
Yeah,
hours.
that's why I'm asking, because I have to go 5 o'clock, so that's why I'm asking.
Yeah, I don't think it will go till 5 o'clock, but it depends on number of questions from your side, right?
Yeah.
Yeah, but
Also,
aim is
class.
to have it. Yeah, the aim is to do it in 2 to 4 time. So that's why I said don't worry about number of slides. They are designed in such a way that it should finish in 2 hours.
We also have
Yes.
a math session today at 4.
Yeah, at 4 o'clock. Yeah, I'm aware that there is a math session, then there is a stat session also after that. Right? There is another stat session after math session, right?
Stat is not there.
Not there. Yeah, okay, fine.
Yeah,
yeah. I just heard that there is some session. CT session, we postpone it to Tuesday because Monday maybe was too early for you guys to watch week 9 lectures. So we wanted to give you one more extra day to watch week 9 lectures before coming to this session.
Okay.
That's why we postpone it to Tuesday.
So it's 4 to 6. There is math session, but I don't have maths. I have to go somewhere.
Yeah, sure, Sapna. We'll definitely finish before that.
Okay.
Yeah.
Because I was like, जो सेशंस लाइव सेशंस में अटेंड कर लेते हैं उस टाइम पे तो हो जाता है, बट आफ्टर दैट वी कांट कवर दैट सेशंस एंड कांट गिव दैट मच ऑफ टाइम to watch your lectures. And it is so beneficial for us to join this live session, so that's why I don't want to miss any okay, sir left.
Hi everyone, this is Rahul. Am I audible?
Yes, sir. Good afternoon, sir.
Good afternoon.
Yes,
Good
Rahul.
afternoon. Omkar is facing some electricity issue, so let's
Yeah.
continue from there. May I know which slide he was on?
26.
26.
Okay, give me some fraction of time.
It's a second question, sir.
Okay, okay.
Second question, we haven't, sir, haven't yet answered which is correct. We only submitted our
Yes,
answers.
it's submitting the answer.
Yeah.
Okay. Thanks. So one more problem you can face is that, I mean, you will have to again join joinpd.com. The code will be different because I'm doing it from my side. Okay. So
Okay, okay, sir.
you need
No
to,
issues.
no problem.
Okay, sir.
Will you please share that code?
Yeah, sure. Guys, I just have sent the code for join PD.
Yes, sir. Thank you.
ESYWIK. Are you guys able to join, everyone?
Yes, sir. Done.
Only 13 students I can see.
Yes, just joined.
Yes, sir. Done.
Join, sir.
So this is problem number 2, I guess you guys were discussing.
Yes, sir.
Okay, so sorry, problem number 2. A robotics student is designing a live falling robot.
Yeah.
The robot can either move one step left or one step right at a time. Okay. The sequence of moves of the bot is recorded in a list rows. Okay. For example,
Excuse me, sir. So your
Yes.
screen is not visible.
I guess you must be seeing the PPT on the joint PD.
Yes, it's visible
Yes,
on the
sir.
joint.
We can. Yeah, it is visible, but I was like, you haven't yet shared
That is sufficient
your
for
screen.
this lesson.
Okay, okay.
Okay. So write a procedure that accepts the list of moves and returns to if the bot is at the same place where it started and false otherwise. Fine. Okay. Procedure is state moves. If numeric moves equal to 0, return true, else return false. Okay. Okay, so how many of you, which option, I mean,
Sir, we have
what
to
is
yet
the code?
respond. We have to respond yet. If you could put it in that. You have to still respond.
We had already responded to this question. We have to respond again because you made new that.
Yes.
That's fine. That's fine. I mean, I think it's one line code, no?
Yes,
Yeah.
sir.
Yeah, please do it.
Done, sir.
Fine. Let others do.
Sir, we can discuss, sir.
Okay.
Actually, sir has given enough time, like approximately we already spent 10 minutes, sir, on this.
Okay. Okay. So what is the answer then?
Like return numeric rest of L minus 1.
Okay, I can see return numeric rest of L minus 1, but I can see also plus 1. Return
Plus 1 for the right and minus 1 for the left.
Yes, sir. Return numeric, return in bracket, right, left, bracket close, then minus 1 plus 1.
Okay. So I guess most of you have given this answer. Is my response visible?
No, sir.
Screen is not. I didn't get what to do here. I wrote it wrongly.
What
So
did you
your
do?
screen is not visible.
Oh, let it be now. Whatever. Okay, you want to see the screen, then you will have to take this. Is this visible now?
Yes, sir.
Yes, sir. Now it is visible.
So this one is most common answer, return numeric rest L minus 1. Okay. Fine. Who has given this answer? Return initial L minus 1. Who has given this answer? Numeric initial init L minus 1. And that is not a return statement also. Okay, by chance. Return true. Nice.
This if I wrote. You press
Why?
first cell equals to right, then return 0.
Okay. So this is how you are making the system to be biased now. Rest first L you are saying. You mean you are talking about the second element. Am I right?
Yes, yes.
And second element, if second element is right, then you want to return 0. Why?
Because the first left, right, and again right, then that robot is at the same place, then there is no steps. Reached at the same position.
It's not mentioned that steps are finished after step 2. It may continue to third, fourth, fifth steps.
So
yeah, again it will repeat.
Again it will repeat means I did not understand, Sandhya. Yeah, someone is saying something.
So my answer is not visible here. Why?
What answer did you give?
I gave numeric bracket right left and then minus plus minus 1 plus 1.
फायदा क्या -1 +1 दोनों देने का?
Sir, it is just like to get the original position. That's why we gave, no?
This one?
Yeah.
Okay, numeric. First thing, this is totally, I'm not sure why. Are you seriously? Numeric is accepting a list, and you are what are you trying to give?
Oh, sorry, sir. I haven't yet made it listed. Oh, sorry.
So even if you provide a list, and this one is minus plus 1, it means you are trying to say that numeric right, left plus 0. What does it make effect? And it's not a return statement. Am I right?
Yeah, it is not.
Is that what you meant also?
No, sir.
Do we
Okay,
expect
so
these type of questions in the end term to write?
अरे संध्या जी आप फिर से पास होने लगी, फेल होने लगी.
तो पास होना है ना.
ठीक है, थोड़ा बहुत टफ तो आएगा. Okay, so thing is, when you are going right, then you are saying return a rest of L. Rest of L means we are dropping the first element, correct? And we are adding +1. Is that right?
Yes, sir.
So to counterbalance it, if you do go left and right and left and right, or somewhere whenever you go to left, you make it -1. Whenever you go to right, you are making it +1. Eventually, what will it make at the end?
Hopefully 0.
It will return the
1 + 1.
Summation 0.
Or some negative.
But if more lefts are there, for suppose 10 lefts are there, 5 rights are there, then it will give 5, na?
It will give 5. So what will procedure is start give?
False. False. Yes, right. Correct answer.
Yeah.
So simply we are what here is happening. We are taking the first element out. We are checking it is left or right. We are giving it a weightage. Weightage, you understand?
Yeah.
Till now, you
Yes,
might
sir.
understand weightage. I mean, the labeled graph you have seen, na?
Yes, sir.
So whenever I'm moving to right, I'm actually counting it a 1 plus I have moved from the original position, correct?
Yes.
Yes, sir.
Again, someone is coming and taking right, 2 I have moved. So to counterbalance it, we are saying it is
2 moves.
2 moves. Okay.
Yes, sir.
Yes.
So I hope, does anyone have any query here?
No, sir.
No, sir. It is clear, sir.
It's clear.
Sir, could you show the answer, please? The code.
दिख गया?
Sir, could you show the code? Oh,
No,
okay.
sir.
I couldn't see.
Instead of rest, if init there, then also it's true, right?
What?
Instead of rest, if in it is there, in it, both in it.
दोनों में init होगा तो चलेगा.
वही दोनों का ही पूछ रही हूँ. दोनों में in it होगा तो it's okay ना?
Yeah.
Okay.
So, whoever has not understood, this is just the explanation. Left, right, left, right, left, 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 left. So sum is 0. That's what it's trying to tell. Now, whenever I take first L, rest L will be this. I don't think I need to explain. Is there anyone who wants me to explain, please?
No, sir.
Because after this 4 o'clock there is a session, I guess. So
Yes,
some-
sir. Math session is there.
I
4 to
didn't
6.
understood, sir, this.
Yes.
Sir, I need you to explain this, sir. I didn't get it.
Okay, so
Sir, it's better to you to explain, because if we explain, no one will understand, because whatever we explain, we only can get that, not others.
okay,
I thought
suppose you have this left, right concept. Okay, so there is a
Okay.
list which has 2 lefts, 2 right. Okay.
Okay.
Now you can understand that this is actually lead me to the original position.
Original position.
Fine.
Yes, sir.
Okay. So once you go to the left, then you are taking right. What does it mean? You went somewhere and come back, correct?
Yes, sir.
Again, you are taking right and coming back. So it should be actually, so this gives me a sense that if numeric when returns 0, then it will be true. Means whenever I am getting a return of a numeric procedure 0, it means we are
Sir.
getting the same position.
Sir,
Okay.
what this is giving, sir, in return numeric rest L -1. Numeric rest L is giving what?
Okay. So see, I understood now your problem. This is the list, correct?
Yes, sir.
At the first, what you are supposed to take, it's saying if list is left, okay?
Yes, sir.
So rest will be what? Right, left, correct?
Yes, sir.
So it's recursion. You need to understand first. Now,
Yes, sir. Again, I'm putting this into the numeric rest. Yeah. Okay, sir.
Numeric rest.
I got it. I got this. But first of L will be right, then.
Okay.
Am I audible, sir?
But it, you are audible. I mean, just give me a
I am
second.
putting this rest L again in the procedure numeric L. Again, I am coming here. If first of L is left, then I am entering this, but it is not left.
What is happening? See, when it will be first left now,
yes,
you'll
sir.
get return. Is that right?
Yes, sir.
Yes, sir.
Numeric of rest of list L. Tell me what is it?
Rest of L is the rest list.
Right, left. Right, left will return here.
Numeric of that list, rest list.
Okay. Give me some time. Okay. Now -1. This is what you will get. Okay. This will be executed. Am I right or not?
Are you writing somewhere?
I'm not able to see what you are writing. Yes, sir.
Yes, sir.
Not
Even we
visible,
can't see your cursor.
Sir, first of all, why we are taking that list? Why we cannot take only right or only left?
Now it's okay.
I understood what
now
you
it
are
is
trying to ask. I'll explain later. That first thing, how this is working. Okay. So notepad is visual.
Yes, sir. Visible.
So if for the first element, this will happen. Is that right?
Yes, sir.
Now,
yes, sir. But why we are putting -1 here?
Actually, we are subtracting one element from that.
एक minute. I mean, this is just obvious that by seeing this else condition.
Yes, sir.
This else condition is saying that whenever I'm moving to right, I'm adding 1. So opposite should be taken in the left. That is what.
And if we are moving to the right and subtracting 1, then left will be +1. That way will be also correct, I think.
Yeah, that is also correct.
Yeah, that is also
Either
fine.
way.
Okay.
So
clockwise, anti-clockwise convention.
But it should be given in the question. According to question, you have to respond.
Okay, sir.
Question is already +1.
Okay.
And if I give both the statement empty, then it's very difficult for a student to understand. Okay. So see here, here the recursion works. Now this will be executed fine. This whole part. You understand or not?
Yes, sir.
So what will it happen? It will say return. Again, go to numeric, and this will be executed, and will say again give me some return. Okay.
Yes, sir.
Rest of what?
Right, left.
Right, comma,
Left.
Right, left.
Left in the list and
+1.
plus 1. Fine.
Yes, sir. We got it.
Okay. Then this part will be, sorry, numeric I have not written. Return. So यहाँ पे फिर से एक numeric आएगा. Numeric. Okay. Is that confusing anyone? This one will give this whole statement will give this part.
Yes.
Okay. Is that right?
Yes, sir.
Again, abhi return khatam nahi hua hai. This is what recursion tells. It is calling itself again and again. And this will give me.
Sir,
जब last होगा
if I'm not wrong, it will call the numeric rest of the elements minus because until it is not empty. If it is not empty.
You are totally not wrong. You are totally right actually. So it will right will be taken out.
Plus 1 will be there.
Plus 1 will get given. Is that right?
Yes, sir.
Very plus 1.
It means it will return 3 times.
No, 4 times. Even 5 times.
Sir, I don't understand. Which list did we start with?
What did you say?
Right, left.
Right, left, right, right, left.
Left, right.
Now it will give return. So see, now it is left. Fine. What will it give in the final? Can anyone tell me?
0.
What will this give? No,
0.
no. You are wrong.
Empty list -1.
This will give empty list -1, and that empty list will be passed to the numerical.
Okay.
So ये आपस में जुड़, so when it will be empty, then it will give 0.
Yeah.
Okay, if I write
And
final,
the above if condition will be true, return 0, right, sir?
Again, please.
Right now we are following the second if condition. In that we are following else condition, right, sir? After that, at the end we will follow the first if condition.
So when we follow
to make it 0.
So when rest L is one element left, we'll follow the second if condition, correct?
Yes, sir.
It will give me numeric of empty list. Fine.
Yes, sir.
Numeric of empty list -1. So again it will go and call return numeric, and it will find that it is saying return 0. There you will get 1 0 only. So return means I'll remove all the return part so that you can understand. This will be returning.
So for this type of list, this right left, we are getting 0. Otherwise, if the list does not contain all left right combination, then there is a possibility that will not get 0 there.
So it will not, once it will not get 0, then the other procedure is saying now when it is not 0, it will give false.
Yes, sir. So we will have to consider that also.
That is where we found that original position is known as 0. Okay, 3 things you are finding in this procedure. First thing, this procedure is stat returns true when it is 0, means 0 is the original position.
Yes, sir.
Second thing you are finding, then this +1 else condition, which is saying that whenever I'm moving to right, I'm actually adding +1. So based on that, third thing, we are assuming that, and we are understanding that return numeric list L will counterbalance when I do the -1.
Got it, sir.
Yes, sir.
Okay.
Yes, sir. It's clear, sir.
Okay. So I will stop presenting and I will go to the next question. Which
Yes, sir.
is
It's clear but quite confusing.
क्या confusion है? What is the confusion?
ये सब return क्या कर रहा है? It's really confusing.
So
Now
whenever
I got the correct. Now I got clearly. If possible, may I?
yeah.
It is just like if we move right, if we are standing at one place and we move left to the side, then after that, if we return back to the original position, it means after going left, we go right to get the original position. Right, sir?
Yeah.
So it is just like if we go.
That one is okay. I'm telling you about the pseudo code return.
Yeah. This is what I'm explaining. Wait, like if we move to the original position, it means if suppose we are going to left side, okay, to the original
Sandhya,
position.
1 minute.
It means we add 1 point in it. If we minus 1.8, then we get the original position. Sorry, sir. What did you say?
Just 1 minute. Sandhya, let's come and solve this question. Okay.
Okay.
Okay. So
that's why I'm saying, sir. If you
Sandhya,
don't explain, then okay. Please continue.
Yeah, this is the list. What will happen? Tell me.
Length is 0. Length is not 0. Then it will go to second if. If L equals to left, no. It will go to the else. Now return numeric rest L.
Okay, return numeric rest L. I'll say numeric of now I'm not going to write return. Okay.
Okay.
You understand that part is just to show that what is to be returned.
Yes.
Return numeric rest and +1, correct?
Yes, +1.
Rest L will be what? You tell me.
Right, left, right.
Okay.
Yeah.
Control.
Except first right.
Not the whole. Yeah.
Okay.
But sir, except the first.
Okay.
Yes.
Now this is also again the procedure calling. Is that right?
Yes.
Yeah.
Sandhya?
Yes.
अब बताओ अब क्या होगा next?
Now our list will be this one, fresh list. Right, left, right. Now it's not left, it won't enter, and again it will come to the else part.
Okay.
Now the rest of list, left, right.
Okay, rest of list will be left, right.
Yeah,
and it is
+1.
saying that give me +1. Is that right?
Yes.
Here.
Yes.
+1 पहले से था. I'm not going to touch it.
This is what I'm little bit confused here. +1 and +1. Achha, it will again give. Okay.
So this is, you forget about this, na? You forget about these things. You don't care. It is just one more step you are writing. What will this numeric give? You tell me. Numeric give me a numeric rest of L +1, correct?
Yes.
So +1
I have
is
doubt that how it is adding +1. I'm thinking it will give only +1.
No.
As per the pseudocode.
No. This +1 is now here. This is separate now. This is again.
Okay. Now I understood.
This one is a procedure calling, okay?
Yes.
And
now
this +1 is something. Rather than writing +1, you say plus something, and you remember what it is.
Yes.
So we just
Now,
need to see this procedure call, sir.
something. Okay. Now +1 +1, it will get 2. Now something is actually updated, correct?
Yes, yes. Now understood. Now understood. No need to go ahead. Thank you. Clear.
Fine.
Yes, clear. Understood.
Okay, okay.
Yeah, Rahul.
Excuse me, sir. The +1, I mean, for each step, it is happening in mid, right? Not at the end. +1 just after this left, right, isn't it?
After you are calling, after numeric list of L, the plus or minus will come.
Got it, sir. Not at
And
the
the other one was returned by the earlier call. The previous
when the
call.
numeric is empty, it will sum up and give the value, right?
Okay, okay, Sandhya, let's finish this now. If you started.
Okay, fine, fine. Let's finish.
So this is actually 2 now. You agree?
Yes, 2.
And this will become
left, right.
Only left, right will be left?
Yes.
Okay, leave it. Now, this will be plus or minus 1.
This one left -1.
Super. So -1. What will it actually become?
1.
So totally, I'll say
+1. Total is +1.
It's +1. Fine.
Yes.
So rather saying there +1, I'll just say there. Now again, tell me again the procedure will be called. Fine.
Yes. Again, it will go for the left and -1.
Numeric.
Right.
Right.
-1.
+1.
-1.
It will
And then
become 0.
+1.
+1. Yes, 1.
Okay, what will happen?
0.
It will be numeric.
Numeric right only.
Right.
Right. Okay, what is this? 0?
Yes, sir. 0.
Now again procedure is being called, Sandhya. Is that right?
Yes.
What will happen? Tell me. Numeric?
Are we executing till the length of 0 or 1?
I don't know what is happening. Still we have one element now. So what will it be?
We initiated with less than or equals to 1 or 0. That's not visible here.
We initiated when length is equal to 0.
Now it will return 1, sir.
Equal to, okay, now it will give
1.
It will give
+1.
list +1.
Yes.
Is that
Empty
right?
list +1.
Yeah.
Yes,
That's
sir.
1, right?
Yeah.
And then +0 is already there. Okay.
Yes, sir.
What will it happen? Become numeric.
Empty list
Empty list
+1.
+1. Okay.
Yes, sir.
Come to this part. Now it will call the procedure again and it will say by this time length is 0. Fine.
Yes, yes.
Then
Yes,
return
sir.
0 and it will return 0. And here the execution will be finished and it will give 1. Fine. So return
Yes,
will be
sir.
1. Now,
One second, you said if length is 0, return 0. Length is 0 only, right? Now.
yeah, so that's why it returned 0 now here.
Yes.
And +1 was already there.
Ah, okay.
One important thing that this is called the base case. When it should come out to the recursion part. So whenever you are writing a recursion, base case is the most important thing. You need to understand where is the base case.
Yes, sir.
But this 0 + 1, yeah, how to judge where is the base case? This return value will add up to 1.
Earlier it was calling the procedure. In this whole step, you are calling numeric again. Fine.
Okay.
After this, no calling, only returning.
Ah, okay, fine.
Okay. Yeah, Omkar, you can take.
Yeah, I'll take it from here. You can stop sharing.
Do we have to join again this join PD?
Yes,
Yeah,
Omkar.
that they will have to do, right?
Yeah. Just share the code. They will join.
Yeah.
Okay, only half an hour left. I'll you go through this.
I think this question is done, sir. We can move to next question.
Yes.
Yeah.
I'll open the question for response, Omkar. Explanation part you take care. Okay.
But then for that you will have to be here throughout.
No, the explanation is finished. We can move to the next question.
Guys,
Yes,
hold on. Rahul, but for that you will have to be here to change slide, no?
Okay. It will take 2 minutes to get change.
Yeah, exactly.
Okay, fine.
Yeah.
Thanks, guys.
Thank you, sir.
So yeah, I've started sharing. Let me take it from where Rahul left. So now only one small thing you have to do. Another effort is go back, use the previous code again.
Okay, sir.
Yeah, I'm sorry for this, but it's out of control. Yes, and only one more question is remaining. I know 30 minutes are remaining, but just one more question is there. So just let's start with this. Now the next part is based on DFS algorithm, depth first search algorithm, and that's the last question. I know more than half slides are remaining, but still it's fine. Okay, so please join this this peer deck using this code XLILEO. Okay, so and this is the question. This is a prerequisite for the actual question, but it's a pretty straightforward one. That given a graph, you have to give me the list of nodes in which the graph will be explored in terms of with respect to DFS. And if there is a place where you have to make a choice between two nodes, then you will go ahead with the smaller label. You start with 0. So from 0, you have multiple options. You should choose the one with the smallest possible label. Once again, you have to type it with comma separated values. I mean, for example, your answer is, let's say 2, 2, 1, 3, 4. You type it like 2, 1, 3, 4, likewise. Yeah, so I got first response. Okay, the options are there. Okay. Yes, come on, guys. It's very easy and straightforward question. Doesn't even involve pseudocode.
Yes, sir. It is done, sir.
Okay, I'm seeing some 16
done, sir.
responses. Yeah, but only 16 responses so far. Let's give another 30 seconds.
Yeah, done.
Okay, 20, 21.
So what was the code?
Yeah, we'll go to code. This is a
It's a joining code.
Okay, joining code is
XLILEO. It's on the chat also.
It's not visible, but I have joined.
yes, only 24 responses. What about others? Guys, if you're not talking, please keep yourself on mute. All right, last 10 seconds. Only 29 responses. So what we are supposed to do over here, we are supposed to find the sequence of nodes which we will visit if we execute depth.
Yes, sir.
So let's see what these 33 responses are. Oh, there is a close fight between option B and C, and A. No, very less number of people have selected. All right, fine. Let's see.
C is correct. I thought
as
so.
per you, right? Yeah. So everyone will
I
have.
marked C.
Yeah, fine. So everyone will have their own choices. Let's see whether B or C, which one is correct. So let's start with 0. Same thing. 0 is the ongoing node. The yellow is the suspended one, and red is the completed one. The same thing which we started from question 1. Okay. So we start with 0, vertex 0. And from 0 now, how many possible vertex are there? I mean, possible nodes are there. There are 4 possible nodes, right?
4. Yeah.
0, 1, 4, 5, and 2. And as per the given statement, we are supposed to choose the smaller one. The one with smaller label. So that means we are supposed to choose 1, right?
Yeah.
So we selected 1. That's the next one. Now we should not go back to 0. 0 is suspended. The current one is 1. So from 1, now we should check what all possibilities are there. From 1, the only remaining possibility is 3. So we must have to go to 3. Now from 3, now 3 is the current one. Now from 3, there are 2 possibilities, 4 and 5. So we should go with 4.
4.
Now there is a problem. Not a problem, but this is the place where we stuck at 4. Now there is no way to go ahead from 4. There is no unvisited node from 4. And this is the place where what we should do, we should go back one step. So there wasn't any way to go ahead from 4. So what we do, we go to the jump
back
to the
to 3.
Back to 3. It's called backtracking. So backtrack to previous node, which is 3.
Yeah.
Went back. Okay. So at 3, again, as you can see, we went back to 3 because 4 is completed now, right? 4 is completed. There wasn't any going ahead. So we went to close the 4, back to 3. From 3, what are the possibilities?
5.
There is only one possibility, which is 5. So now suspend 3, go to 5. Now from 5, what is the next possibility? Which is 6. Go to 6 again. Now at 6, if you observe, there is nothing going further. There is no option from 6. So what we should do?
Back to
suspend 6.
Sorry,
suspend. Close 6. That completes 6. So 6 will be marked with red. Now 5 is active. Again at 5, there is no going further. Close 5, go back to 3.
3.
Now from 3, again there is no way to no going further. Close 3, go back to 1. Again from 1, there is no way further. Close it or complete it, go back 0. Now explore 2. Again from 2, there is no option. Close it, go back. Now again at 0, no option. Close it. That's our final answer.
Yes, sir.
That is DFS algorithm, depth first search.
Yes.
So far, any doubts?
No, sir.
I mean, this was just the algorithm. Now we will go, I mean, as you can see, problem 3 is prelude, right? That's not the actual question. Now we'll go to Sudoku. Okay.
Sir,
but in order to understand, sorry.
I wanted to ask something, sir, in this.
Yeah, tell me.
Sir, after 3, why did we go to 5, sir? Why did we go to 4 instead of going to 5?
4 was already there, right? See, 4 was there.
5 is also there, no, sir.
Sorry?
5 is also there, 4 is also there.
Yeah,
Then
so
which node we
I
should choose?
see at okay, understand this. At this point, the option is between 3 and 4. We have 4 and 5. We have to choose one, right?
Yes, sir.
And it is told, what is told to us, that if you have a choice, then you should select the one with smaller label. That was written in the part of the question, right?
Okay, sir.
So which one is smaller, 4 or 5?
4 is smaller, sir.
4 is smaller, so we went ahead with, that's why we selected 4 first. The same logic we applied even initially. See, what was in case of ties, that there is a tie, choose the node with smaller label. So at 0, we had choice between 1, 4, 5 and 2. 4 choices were there. There was a tie between these 4 nodes. Why we selected 1? Because
it is the smallest.
It is smallest among 1, 4, 5, 2, right? Same logic. You just have to keep applying same logic till we reach the end. All right. Is that clear, Kaushal, right?
Yes, sir.
Yeah.
Yes, sir. That means length of 5 is connected to another one 6 node. That doesn't depend whether we should select that.
No. We are not talking about length or anything. It's just the label value. Label is one is smaller than other labels, right? It is about label of the node. If it is A, B, C, D, E, F, G, then what? We just find the alphabet which is small, which is the smaller term may not be right. The one which is in the alphabetical order. So if you have option between, let's say, B, C, Z, and E, then what you should choose B, right? The B is the first one in the alphabetical order, right? Same thing.
Yes.
Yeah. So that is something which is which will be mentioned as part of the question. That what should be your choice when there is a tie. All right. Yeah. So with that, can we move to actual question now? If the DFS algorithm is clear.
Yeah.
So this is just to check whether you understand how DFS works. So if you know how DFS works, now the actual question. Okay. So the next part of it, I will say, which is constructing the tree using the DFS algorithm. Now at this stage, now we know that these are the nodes which got visited. But DFS is the depth first search tree, right? This is still not a tree. This is a graph. In tree, there should not be any cycles. So we have to extract a tree from this particular graph. So that should be our next step. Construct the tree corresponding to the depth first traversal of this graph. This is the traversal. These numbers 0, 1, 3, 4, 5, 6, 2. Now from this, we should extract the actual tree. That is first step. Okay. So let's extract that tree from here. How to extract that tree? Same thing we'll do again. Only thing is, this time there is additional thing which we will do. We will, whatever DFS algorithm we did, right, with this, we'll add arrows into it. Now we'll see how to do that. Okay, this is important for the actual question, which is problem number 3. That's why it says the prelude of question problem 3. Right?
Yes, sir.
So we started from 0, we picked 1. Now, how from where we reach to 1? From 0 we reach to 1, right?
Yeah.
So there is a path from 0 to 1. 0 is a parent, 1 become child of it. I hope you understand this hierarchy of parent-child, right? That means there is an arrow going from 0 to 1. Similarly, from 1, where we went from 1, we went to 3.
3.
So there should be an arrow going from 1 to 3, the age going from 1 to 3. Now 1 became parent of 3. Now from 3, what we did? We went to
5.
Sorry,
4.
We went to 4. So there is an age from 3 to 4. Now this is the point where we got stuck, right? From 4, there is no going further. So we went back to 3. Now from 3, we went again to 5.
5.
So from
it means
3, from 3, there are 2 outgoing edges now. 3 to 4 and now 3 to 5.
Sir?
Yeah.
Yeah.
Sir, it means 3 has two child.
Correct.
4 and 5.
Yes, correct. 3 has now 2 childs, 4 and 5. Now we are at 5. From 5, now 5 has 6 as a child. Now again we got stuck at 6. Go back to 5. Again from 5 there is no possibility of another child. Go back to 3. Go back to 1. Go back to 0. Now 0 will have another child, which is 2.
Yeah.
And this same thing where you can draw it in a more, in a slightly different manner so that it's easier to understand, which is like, okay, hold on.
Tree.
Yeah, like this, like a tree.
Yeah. Yeah.
Now, if you see, these two edges, right, these gray colored ones, they are got removed. The 0, 4 and 0, 5 got removed. Now, this originally it was a graph. Now we got the tree without any cycle. Starting from 0 to 2, 0 has 2 childs, 1 has only 1 child, 3 has 2 childs, 5 has 1 child. Right?
Yeah.
This is depth first tree. Original
Yes,
input.
sir.
So for depth first search, the original input was a graph and the output is tree. All right?
Yes, sir. Cleared.
Right. So I believe so far, is it clear? Because this understanding is
sir.
important in order to
Yes.
answer the actual question.
Yes, clear.
Yes, sir. All right. So let's actually see the next question. So the question is, write a recursive procedure to traverse this graph in a depth first manner, starting from any given node I. Now we don't know what that I is. I can be any input asked to that particular procedure. Okay. In previous example, we started from 0. Now it's a variable. It can be hold any value. And then compute the depth first search tree corresponding to traversal. Same thing what we did, but now we are supposed to do all that thing using a pseudocode, right?
Okay,
and this
sir.
is your question. This pseudocode is given to you. These are 4 parameters, or you say these are 4 data structures or variables which are very key in order to solve DFS, right? So A matrix will hold this particular graph. Okay. This particular graph is represented using matrix A. I believe at this point of time, you know how to convert a graph to a matrix.
Yes.
Right? Now, it's bit a slightly
Yes, sir.
complicated code. I will give you 5 minutes. Think about it and submit the answer. And I believe for this one, options are not there, right? Again, you'll have to type the code. Type the code for this, fill the code.
Yes, sir. We have to write the code in it.
Yes, you have to write a code, and once again, just a small hint, it's a single line code. Okay, so don't think too much, it's a single line code. Just like that previous question. Any doubts so far?
No, sir, not yet.
Okay.
Sir, I'm done.
Yeah, I'm looking at your submissions. Almost all are correct, but there are small mistakes, some silly mistakes few people have made, but otherwise it looks fine. See, remember, whenever you call a procedure returns something all the time. So whenever something gets returned, you should store it somewhere. It's not always return, the return call has to be there.
Yes, sir.
Think about that. And that J over there is a small j, not a capital J. Only other variables are capital letters. The J is in lowercase. So if your answer has that mistake, please fix it.
Sir,
Yes.
Is DFS is in capital or in a small letter?
You tell me, what is the procedure?
Actually, I did it in a small by mistake.
You are calling a procedure, right?
Yes, sir. Can I edit my?
Yeah, you can edit. Yes, you can edit.
Okay. Because I just remember, I just like I made a mistake in it.
Yeah, go ahead, edit it.
So is it mean here syntax matters, how it is written?
Yes, see, with respect to computational thinking or any programming language, this case matters. Case as in the uppercase or lowercase is very important. Variable capital A and variable small a are two different variables for any programming language. You cannot treat them equally.
But sir, in programming,
same thing goes for procedure name as well.
Yes, sir, I know. Like in programming, it matters because there is their code is different. Like their number is different. But sir, here in computational thinking, we haven't yet get the proper syntax, gone through the proper syntax. So that's why I'm asking, like, is it matter here or not?
Yeah, it matters. It matters. See, here also the proper syntax is there, right? Whenever we write a procedure, there is a standard structure which is followed.
Yeah.
It may not be specific to any programming language, but we have our own syntax, right?
Yeah.
Square brackets has specific meaning. Curly bracket has some meaning.
Yeah.
If everything has the for each, while, if it may not be relevant to any specific programming language, but it's a syntax. It's our own syntax. Actually, we all sat together and we created this syntax. But yeah, it is a syntax.
Yeah. Okay.
And you will know that why we created this syntax when you start with Python and then with Java.
Yeah.
We have taken we have this syntax is created by taking some motivation from Python and some motivation from Java, so that when you actually learn those languages, you will feel some familiarity to that code.
Yes, sir.
Okay, so 18 responses so far. Almost they are correct. With small minor mistakes are there, as I said, but otherwise they are fine. I believe these are the only people who have watched lectures.
Yes, sir, I did already.
I am sure these 19 people who submitted, they have watched lectures. At least most of them have. Otherwise, it may not be that straightforward to submit the answer. All right, so let's see what the submissions are, and then we'll see what's the correct answer, and we'll take it from there. So as you can see, these are the submissions, and that is what I was talking about. For example, this one, DFS call. I don't know who the person is. I mean, that that logs get maintained on the back end, but APSJ. This is absolutely correct. Only thing is, when you write, whenever you call a procedure, it always returns something, and that is what I was talking about. When you call a procedure, it returns something which has to be stored in something. So this P comma S is important. Just making a DFS of APSJ may not work. I am not saying this is the correct answer and this is incorrect, but this is the part I was talking about. Whenever you call a procedure, it will return something and you should have some way to store it. Either just S is equal to DFS or P comma S is equal to DFS or something like that. I don't know what this return DFS is, but yeah, some way has to be there in order to store the returned value, which is there in most of the cases, but somewhere it's missing. That's why I wanted to point that out. All right, now let's start with what the correct answer and why that is correct. So the correct answer is P comma S is equal to DFS of APSJ.
Yes, sir. I did this.
It wasn't that actually difficult, because see, look at the original procedure call. Yeah. Even in the previous question, the original procedure code was APS, and only this one was changing. I was our initial one, but then we changed the initial. I mean, we are iterating over J, right? So initially we started, let's say, for example, from 0. For next time, we chose 1, right? I mean, as per the previous example we saw, from 0 we went to 1. So the same procedure has to be executed considering 1 as a starting point, and that 1 came from that J. That is why this APSJ, that's how it should be. I mean, that's the only subtle difference. And every time this thing gets evaluated, what will change? P and S. What is P and S? P is a dictionary which will maintain whose parent and whose child, and S is a list which will maintain what all nodes are visited so far. So if you go back to our original question, this is that list. That S list will hold this. But at the same time, we should know whose parent and whose child. That means 0 will have, 0 being a parent, it will have 2 childs, 1 and 2. So this thing has to be somewhere reflected in the data structure, and that can be done only using a dictionary. A dictionary key will be 1, value will be 0. Dictionary key will be 2, value will be 0. So for 1 and 2 keys in dictionary, value will be 0. Why? Because for 1 and 2, the parent is 0. Yeah. So that is that dictionary. Now, I mean, this is just the overview. Now I will see, actually we'll do it step by step.
Here we're giving two variables P and S the same value.
Correct.
I didn't know we can even do that.
Yeah, we have done this earlier. In many of our pseudocodes, we have done this.
Yes, sir.
I don't recall any.
From the node where we are starting, like
comma and being equated to something. I don't recall that.
Yeah, it is there. You just go back and refer some pseudocodes from graphs. You will see there are many places where we have done something like this.
Yes, you're talking about only in week 9.
No, no, even before that, even from weeks like list and dictionaries, from week 5 onwards, we have done it many times. We are passing some dictionary D, and that same dictionary is getting updated on the left-hand side of equal to sign also. We are passing D and we are storing in D.
No, the updated is fine, but I had not come across this P comma S being equal to a single thing.
That is also there. That is there in week 5 itself. In week 5, no, not week 5. It is there even before that. I think this was first time it came in that 3 price problem. 3 price problem, which is there in week 3 or 4.
Yes, sir.
It is started from there.
On week 4.
Week 4, okay. In week 4, 3 price problem, just watch the pseudocode lecture by Professor Madhavan. Even in that lecture, that is the first time he used it, and it's there many times after that.
Okay, it must have skipped my mind. Thank you.
Yeah, sure. Anyways, fine. Let's continue with it.
Sir, as you have as you have used key as a 1 and 2 and the value as a 0. So why you have not used the 0 as a key and 1 and 2 as a value in a list? format?
Yes, you can, but that is nothing wrong in that, but it becomes easier to iterate if you have a fixed set of structure, right? Because if you create it like that, then every time for that list we'll have to write another iterating loop, right?
Yeah, it would be there.
Yeah, right. Because for every time we first have to check whether it's a list. If it's a list, how many elements are inside? Then you'll have to write a loop to iterate on that that list. So it becomes slightly complicated. Nothing wrong with that logic, but this will it simplifies it, right? That is the only reason I said it that way.
But that look somewhat symmetric in sense in P-language.
Okay.
Sir, one thing I want to add in it, as he said, if we took, we can't, why we haven't took 0 as a key? If we took 0 as a key, then it means 0 as a key and the colon after 1. And in the second, 0 key and colon after 2. Like, then it will contain 2 similar keys.
No. He is not saying that.
Then it
See,
is not
Sapna,
possible, no?
Sapna. He's not saying two similar keys. Just he's saying one key, but instead of value, store a list of values.
2 values.
Yeah, that's what he's saying. He's saying 0 colon in a list you put 1 and 2.
Okay.
Yeah, but for that, in order to iterate that list, you will require another loop. So it becomes even tricky. That's why. Yeah, but I don't know who said that. Who suggested it?
Yes, it was me.
Yeah, Ram. So Ram, the thing is, your suggestion is correct. There is nothing wrong in that approach. Accordingly, you'll have to change the entire pseudocode.
Okay, sir.
Yeah, okay. Maybe you can give it a shot afterwards.
Yeah, sure.
There's nothing wrong in it.
Okay.
All right. So let's go right now. Let's go ahead with this approach. So we will start executing it. Okay. First, in order to do it with some example, we should have some starting point. So this time, let's start with I is equal to 2. So let's assume I is equal to 2, and then we'll execute the whole procedure. All right. So with that assumption, let me begin. So right now our I is 2. So our what is the P? P of I is -1. So that came from pseudocode. Now you see at the top, the variable values will keep updating as per the highlighted row of that particular code. So right now we executed these 3 lines. Accordingly, those 3 variable values changed. Okay. Now let's go ahead. Now the first procedure call, P is equal to DFS, where I is now 2. We know. So now 2 is a ongoing procedure call. So with that, now we started the procedure. S is equal to S plus plus I. Because of that, now S, if you remember, S was empty list earlier. Now S holds 2. Okay. So now keep looking at these 3 things parallel. I will slowly change slides and I will try to explain as much as possible. But you have to look at 3 places: change of the values of variables, which line we are executing in pseudocode, and the graph where these node colors are changing. And that's why number of slides are that high, because for every iteration there is a new slide. Okay. So now next line, for each j in columns of A, the first line we executed. Now here what we are doing, A of ij is equal to 1. What is A of ij? I is 2, j is 0. So 2 0. Are we checking whether it's 1 or not? Yes, 2 0 is 1.
Yeah, it is 1.
It is 1. Then we are checking is key P of j. In this dictionary P, we are checking whether j is a key or not. J is what? 0. We are checking whether 0 is there or not, but it's not. So is key will return false. Not of false is true. So true and true if condition is satisfied. So we should execute whatever is inside, which is P of j is equal to I. What is P of j? We added that 0 as a key and initialized value as 2.
Sir, it is just like if it is not given, then we are putting that in it. Like 0 is not in that key. First we check 0 is there or not. If it is not, then we are putting in it.
Correct. If it is already there, what is the meaning of that? That means it is already visited. right?
Yeah, it means
that node
it
is
is,
already visited. You're not supposed to check to visit same node again as per DFS. That is why we are checking whether it is there or not. If it is there, we will not do anything. If it is not there, then we should add it and assign some value.
So,
Yeah.
may I add something in it?
Yeah, sure.
So, as someone said, like 0 has a 1 and 2, 1 comma 2 is not there. Here, this condition is not possible for that. Here we have to change this.
No, that is
To
possible,
make-
Sapna.
to
But
make-
yeah, Sapna, that is possible. For that, you will have to check the values, whether this value is there or not. Right now, we are checking whether this key is there or not. As
Okay.
per the Ram's suggestion, then we'll have to check whether that value is there or not. As I said, it is possible. Only thing, the code gets complicated if you do that way.
Yeah.
Okay, that, I mean, there is a way to do everything. Only thing, the either it will be a simplified code or it will be a complex code. That's all. Okay. So
Sir, what is column A, sir, in this?
Column A is not a column. A is that okay, columns of A.
Yes, sir.
Columns of A is a matrix, right? So columns of A will give you all these values from 0 to 6. So it will return so J will start from 0, then 1, 2, 3, 4, 5, 6. That will be the value of J. It will go from 0 to 6.
Okay,
See, this is not new. This came in week 7. Columns of A is from week 7.
Yes, sir. Yes, sir.
Yeah.
If supposing we had started with 0, just I know we already started with 2. If we had started with 0, then what would have happened? That it would have already returned. It wouldn't have ended because is not key would not have been satisfied, right?
See, if the key is not there, right? In that case, what we will do? We will get 0, 0, right?
Yes,
sir. J will become 0, and we started with 0, but 0 will have some value which is minus 1. 0 is already there. It's already there. So if condition will fail, we will not execute inner thing. Then J will become 1.
Yeah. Okay. So
J will become 1, and J1 is not there. So we will execute this for that.
Okay.
Okay. Same thing. I mean, no, it doesn't matter what the value of I is. Same thing should execute, right?
Okay.
Yeah. So let's continue with this. Now we are at 2, right? From 2, now we have added this 0, 2 because now 0 is what? Is a child of 2. 2 is a parent, 0 is a child, as we were talking earlier.
Yeah.
Now we reach 0. From 0, we should start it again. That means what? Now the past value should be, okay, sorry, I should go step ahead of that. Okay. From here, now J is passed. Now J became 1, right? Earlier it was 0. Now J got updated to 1. Right?
Yes.
So
Sir.
the second iteration. In that, we again, okay, over here, we are now looking for 1, right? The node 1. Is 1 key in P?
No, sir.
It's not there, right? It's not there. That means what? We're supposed to add it.
Yeah.
So let's add that. And the parent is I,
0.
right? As per this B of J is equal to I.
Yeah.
So I is updated value is 0. So 1:0 got added because of that. Now where we have reached? We have reached to 1, right?
1.
Now let's start from 1. So from 1, 2 possibilities, right? But J will always have the smaller possibility because we are going from 0 to 6. So it will have next value as 3.
But sir,
Yeah.
Going to 1, we have only one possibility forward because we have gone through 0. So after that, only possibilities left is 3 now.
No, right? I mean, 4 is also a possibility, but the way loop works, for each loop works, it's from 0 to 6.
Okay.
So it will actually take initial value as 0. It will say, okay, 0 is already there. It will skip it. Next iteration, it will take 1. It will find 1 is already there. It will skip it. Then it will take 2. It will find 2 is already there. It will skip it. Then J will become 3.
Okay.
Every time J will start from 0, right? Because when we do new procedure call, for each loop starts from initial, from the beginning with J as 0.
Yes, sir.
Okay, it's not like J is always starting from the previous value. It will always start from 0. Correct? No, correct. No, because we are doing this DFS call again and again. S is equal to S append. From here, everything will happen again and again and again for those many number of times this procedure is called. That's the recursive procedure call. Are you getting it?
Sir, I got a little bit confused after one. Like getting one, we, as you said, we have two options, and I'm saying we have only one option left, which is 3. Why we are watching? Why we are counting 0 as a option left or not? Because as you said, if we move forward, we don't look backward in, because
Yes, correct. What you're saying is correct. But what happens? What will be the first value of J?
0.
0. That means you have to check whether Aij is equal to 1 or not, which is true.
Yeah.
What is the value of I? 1. What is the value of J? 0. 1, 0 is 1.
Yeah, sir.
So this is true.
Yeah.
But because of this each key, it will become false because
Okay.
0 is already there.
Yeah.
So the possibility is there, but it is already visited. How? I mean, it is already explored one. Why? Because it is added in the dictionary.
Okay.
That is what I was talking about. Dictionary will tell you what you have done so far and what is remaining. If it is there in dictionary, that means it's already covered.
Yeah. Because of the not after the end condition, not is key PK.
Not is, yes, that not is important for that purpose.
That's why we are going through all the. Then again we back to the 0 and update that value.
Correct. So only yellow and green colored one. Yellow are what? Which are suspended one. Green is the ongoing one. So ongoing and suspended one will always be there in this dictionary P. But remaining these green, these blue color ones, right? Blue, purple, whatever you call it. It is still not explored. We don't even know whether they exist or not.
Yeah.
They are not there in the dictionary. That is what I was talking about.
Yeah.
Okay. So shall we continue on this?
Yes, sir. Please
Yes,
go
sir.
ahead.
Yes, sir. Please go ahead.
So with that, now we check the next age, which is 1, 3.
Sir, I have a question.
Yeah, Divya.
As we are moving down this branch, if we could call the node at the very end of the branch, it is creating a dictionary with very few keys, maybe just one key. And then we're progressively increasing the keys as we say go down the stack. That is what we're trying to do.
See, there will be, how many nodes are there in this particular graph? 7 nodes?
Yes.
So there should be 7 keys in the dictionary at the end.
Yes.
Because see what we are saying, value represents the child and key represents the child and value represents the parent. So every node will have one parent.
Yeah.
Right? So 6 will have parent, 5 will have parent, 4 will have parent, 3 will have parent. The parent value might be same. That's a possibility, right? Earlier we saw that 2 and 1 both have a parent who's 0. Same parent is possible, but still one key will be there and 2 key will be there. The value might be 0, 0 for both of them.
Yes. And
or some version of it based on what is your initial vertex. I mean, here we started from 2. If we start from something else, the values may change, but always there will be. Yeah,
I understood that. What I'm asking is, like when we're creating these stacks, the one at the topmost is giving a dictionary which has smaller number of keys as compared to the second one in stack and lower one in stack. That is what we're doing.
No, they will always be same, right? In every iteration, one value will get added to list and one value will get added to the dictionary. See, what is happening is every time S is equal to S plus plus I will happen. And for some value of J, P of J equal to I will also happen.
Actually, I'm visualizing backwards from the end of the branch towards, back to the parent. So I'm visualizing that from at the end of the branch, there will be a small dictionary with one key with that node. and then it will progressively go up until we get complete dictionary and complete list.
No, not like that. In every for every DFS call, one value will get added to a list.
Okay.
That what value, what this list represents, this value represents the previous example, right, where you give me that sequence of DFS nodes visited.
Okay.
That is that list. And after that, we did some exercise where we try to convert that graph into a tree.
Yes.
And in order to do that, we should know whose child and whose parent. We know there is an age between 0, 1, and we have decided that. But we should know
dictionary and the list.
Yes, so that is that parent-child relationship is maintained using dictionary, and this list represents the order, the one which you guys submitted as an answer. That is that list.
Okay, got it.
And we need both.
Yes.
Okay. Fine. So let's continue with this. So now we are currently at 1 and we are exploring this 1, 3H. Okay. That means now we are checking whether 3 is there in the dictionary or not, as per this yellow highlighted line over here. Now 3 is not there. So we added 3 and we call the procedure again using 3 as ongoing one.
Yes, sir.
Now from 3 again, we have to check the next age. The smallest one is 4. So we will check 3, 4. Now, if you see, the 4 should get added over here. And now we are explored that 3, 4 thing. Now, as we are exploring that 3, 4, now we know 4 is not there. I mean, it was not there earlier. Now in this dictionary, 4 is not there. So we added 4. Right? We added 4 over there. Yeah.
So here I want to ask, like, we know that we have to move the smallest node. We have to move towards the smallest node. But how the pseudocode knows this?
That is what I am telling you. J will always start from 0 to 6.
Okay. I forget.
Okay.
Okay. Now
Yeah.
I got it.
Yes. All right. So now 3 is ongoing one, and we have just found out that our next target is, or the next place where we should move is 4. That's why we added 4 here. So we should have a call as with J as 4. So next call is 4. And with that, we started from 4. Now, if you look at from 4, right? Now for any value of J, this if condition will fail. You take any value of J, this if condition will fail, because either Aij is not 1 or that key already existed, because 4 has 2 connections, 4, 0 and 4, 3.
Yeah.
Right. So in this case, 4 is our value of I is 4. So 4, 0, 4, 0. Now 0 is already there in the dictionary. So we cannot execute this if. 4, 1. 4, 1 is not equal to 1 because there is no age. For 4, 2, no age. 4, 3, age is there, but 3 is already there in the dictionary. Because of that, this not key will fail. Now 4, 5, age is not there. 4, 6, age is not there. That means for this particular 4, this if will never execute.
Yes, sir. We come out of this.
That means we come out of this for loop and we return PS as it is without any updation.
Yeah.
Right?
Yes, sir.
That means 4 is completed. So when we complete that time, we will return values without any updation. No change will happen to P and S when 4 is going on.
Yes, sir.
Now that is the case. So 4 will become red. See, if you look at these values, right? No change will happen, but 4 will become red.
Yes, sir.
Now after this, we should go back to 3. How we know how to go back to 3? That is taken care by that stack which I was talking about earlier. What was the previous value of I before 4? It was 3. So because of that, in that stack, it will go back to its previous value. Now it will become 3. As you can see, I became 3.
Sir, but from the code, how do we know? I mean, that stack thing is not mentioned in the code.
I mean, it's not, see, stack is not part of the code. That is kept outside.
Okay.
Can you see on the, no, look at this on the right hand side. Right bottom corner. Can you see that stack is maintained? We have maintained that stack.
Yes, sir.
Okay,
Yes, sir.
okay.
Okay, from there we will get it.
Okay.
Okay.
So if we are solving any such problem as of now, so
Yeah.
we will have to assume that after 4, we'll go back to 3, then explore the remaining nodes from 3, right?
See the right now, I mean at the begin at your stage, you should maintain this stack or using pen and paper. Otherwise, you will make mistakes. It's easy, right? Just have to maintain the entry of this, like Rahul was doing, right? He opened one notepad and writing down things like
Yes,
that.
sir. Yes, sir.
You should also do similar thing using pen and paper. So that's it. Initially you do it for few examples, later on you will get used to with it, and then you will not have to do it, right?
Yes, sir.
Remember your days when you started week 1 and week 2, you used to keep track of all variables, but now if I give you some question from week 1, you can do it just by looking at the question, right?
Yes, sir. Yes, sir.
It's just a matter of practice. Once you get used to with it, you will not have to, but initially it's better to maintain that stack over there.
So my question was, from the code, how do I know? I know from 4 I have to go back to 3, because here no condition is satisfied for 4.
Yeah, that is the point. You don't, that is not how, I mean, that is okay. It's clear from the code because it is a nested procedure call. What nested procedure call do? It goes back whenever the return statement execute, it goes back the place where it was called.
Yeah.
When it was called, see.
When I was 3, right?
When I was 3.
Okay.
So it went back there and it again started from there.
Okay, I was confused with this thing, right? Okay, because from code.
Let's do one thing. I mean, I understand this recursion is a bit tricky. Tomorrow, okay. Anyway, on this Thursday or somewhere. I mean, let's see. We'll have extra sessions, right? We will keep having this session. I will come up with some easier slides to explain you how this recursive procedure call and this stack business goes on. Okay.
Okay. We have week 9 submission tomorrow. Completed assignment.
Yes, for week 9 submission is tomorrow.
Yeah.
And I saw these videos long back, but I'm still facing problems. Especially when you ask us to write the code, then I completely.
Yeah, I understand. See, trust me on this. Even somebody who's an instructor of this course will face a problem when there is a recursion. The recursion is not easy concept to understand for anyone. Even for me, recursion is a bit tough. Okay. So don't feel that you are the only one who's facing it. Recursion concept itself is tough. Let me say that on record.
Submit like so you're making.
Yeah, that's why I said, right. I will explain you. I mean, for now, for the submission, I don't think your graded assignment you will face much of a problem. But in order to understand how recursion works internally, right? I will come up with I will come with some good example for that with some better design slides, which I will take you through that in order to explain you how it goes. I will do that.
Yes.
Okay, I will conduct some separate session only for recursion.
Sir, I just want to add. To understand recursion, what recursion is, it is better to have a paper and pencil.
Yes, absolutely. That's why I said take a pen and paper and draw this stack.
Method.
Yes, correct.
So I already did in college, but still I got lots of confusion, lots of doubts in recursion.
Say, I told you I have 10 plus experience doing recursion, but still I struggled till date. Okay, don't think that way.
In DFS, I'm okay with that because I already done in college. But recursion, I still have lots of doubts.
Yeah, it will be there. It will be there.
It took too much time.
Yeah, absolutely. See, first time I heard the word recursion was back in 2007-8.
Okay.
Till today, I think that sometimes recursion is difficult. Okay, so you can you think accordingly, and then you can consider how many years it will take to properly understand recursion. Okay. Yeah, Praveen.
Sir, one request, sir. Can you take more extra practice session, sir, because I
Yes,
am
we will do. We will be doing. I mean, we do those extra sessions which we announce through Telegram, right?
Okay, sir.
We will
Sir,
be doing those
actually,
sessions.
Yes,
I
sir.
am direct entered to diploma programs, sir. So most of the day I am having Python and CT both at the same time. So I
Okay.
can either attend one class only. So I
Okay.
miss many days, sir, classes.
Okay. Are you there in any of those Telegram official Telegram groups
Yes,
where
sir, I
we
am there.
announce about these Google Meet sessions?
Yes, sir. In CT group, I am there.
Okay, fine. So we'll be announcing there and we'll take extra sessions. Okay. And Kaushal, today is the only time for Solve with us where Python and CT is happening at the same time. Usually CT happens on Monday and Python happens on Tuesday.
Sir, even day after tomorrow also we are having
Yeah,
same
Thursday.
time.
Thursday always it gets clashed,
Yes.
but for Monday, Tuesday, that's not the case.
Yeah.
I know I'm an instructor for Python also, so I know what is happening in Python. So yeah, anyway,
Yeah.
Kaushal, we'll see. Okay.
Could you keep one session tomorrow before our graded assignment submission so that
Tomorrow, huh? Let me see based on, I mean, tomorrow actually there is a separate meeting happening with all diploma students. So I might be busy with all diploma students. So Kaushal might be aware of it. There is a meeting at 6 o'clock with all diploma students.
Yes, sir.
Yeah, so
yes, sir, tomorrow.
I'll be busy with that. But anyways, let me see if me, no, not me, then I will check with the other members if any one of them is available.
Deadline of week 11 assignment diploma, and the meeting with the diploma students is also there in 6 to 7.
Yeah, that's what.
So maybe we can move ahead, sir. Next question.
Yeah, let's continue with this question. Yeah. So as I was talking, at 4 we stuck, so we went back to 3, and from 3 now we are continuing again, right? So now our J will again go from 0 to 6, and now for 4 the key is already there, so we will explore 5 because 5 is not there now.
Yes, sir.
That is the case. Now for 3, 5 is not the key, so we'll add 5 into it. 5 got added with 3 along with it. 3 is the parent, 5 is the child. Now the current ongoing one is now will change to 5. 5 is the ongoing one. From 5, the only option which is not there in the dictionary is 6. So next one which we should consider is 6. 6 is now there, not there, so we'll add 6 into dictionary as 6:5. It will get added, and we'll continue from there. Now at 6, there is no further going because now everything is there in the dictionary. So just keep checking if something is there, not there. Just keep closing it. So we'll keep closing the all yellow ones are or all the one are suspended ones. So now we'll start completing them with this last return statement P, S. So there will not be any change in this P and S. I will only keep changing. Right now I is 6. Now I will become the previous one. So I will become 5. Sorry, no, not I. In this case, we were changing the combination of ij. So we'll keep going down through this particular stack from 6 to 5, 4, 3, and so on. So it will keep changing accordingly. So as you see, so that value of this j, right, the one with which we are making the procedure call, that's variable j, will keep changing accordingly. And we will keep closing all these suspended calls. And when all get suspended, that is the place our procedure, our pseudocode is finished. But in all these cases, if you observe, P and S are not going to change.
This is again because this is the standard procedure for DFS, right?
Yes, correct.
From the code, it is not visible. It has to go back, right?
No, it is visible. That is what I'm saying. That is how this nested, not nested. That is how this recursion works.
Okay.
Okay, that is what I was saying. I will okay. I mean, I cannot right now commit a specific day and time, but I will conduct a separate session dedicated only for recursion. Okay, I will do it myself. That much I give you a promise.
Right.
Okay, I will try to do it as soon as possible. Okay, yeah, where I will explain you this particular confusion of where it is there in the code. Okay. And now with the values of P and S, now see, this S will give you the order in which the nodes are explored. We explored 2 first, then 0, 1, 3, 4, 5, 6, which is very clear by looking at list S, which is same thing which you guys submitted initially. But now from S we have to find out the tree, and that is problem 3.2. How from this particular dictionary P, how to derive that particular tree structure. So let's see how to derive that particular structure. How to do it? I mean that pseudocode is not there. You can simply you can write that pseudocode, but let's just I'll tell you how to do it. Find a key whose value is -1, because -1 is not vertex here, but still there will be something whose value is -1, whose parent is -1. That means that's the initial one, which is 2. 2's parent is -1. Now -1 is just some value which we have given to it, just to tell that that's the initial point, right? Now we got 2. Now find all such values where 2 is the value. Now 2 is a value here. I'm not talking about 2 as a key. I'm finding 2 as a value. Now 2 as a value, that means we have to go to 0. 2 is a parent of 0. That's why arrow from 2 to 0. Now from 0 we have to check 0 is a parent for who all. Now 0 is a parent for 1. That's why H from 0 to 1. Now we have to check 1 is a parent for what all vertices. 1 is a parent for 3. So we went from 1 to 3. Now we have to check 1 is a parent for who all. Now, sorry, 3. 3 is a parent for 2 different nodes, 4 and 5. Right? 3 is a parent for 2 different nodes. That means there should be 2 edges from 3 to 4 and 3 to 5. Right? So we'll add them, 3 to 4, 3 to 5. Now we have to check from 4 how many edges are there, from 5 how many edges are there. But at this point itself we know from 4 there are no any edges, because 4 is not appearing on the right side of that column. So from 4 there is no outgoing edge. 4 is not a parent of any node.
Yeah.
Then 5. From 5 we know from 5 6 is there. So from 5, I mean 5 is appearing on the right side of column. That means 5 is a parent of 6. Now 6. Now we are also, I mean visually we know, but logically we have to check whether 6 is appearing on the right side. It's not there. That means 6 is not parent of any node. And that is where we stop. And this is the same, which is the tree which we derived from that particular graph. Now these two gray colored ones will be removed and this tree will be there. And yeah, that's the last slide. Is it clear?
Yes, sir.
Yes, sir. This part is clear, sir.
Okay. Any doubt? Apart from that general idea of recursion, any other doubt?
No, sir.
Okay. Actually, to be honest, we already conducted open session for week 9 last Thursday, where this you should have asked doubts on recursion, but it went on like a quiz 2 revision session. It somehow got converted as a revision session for quiz 2, but that was obvious. So we don't mind, but yeah, that's why we can't. We were not able to do it before the deadline.
Excuse me.
Anyways, yeah, fine. So any doubt?
Sir, same
No.
question again.
Can you hear me?
I want to ask.
Yeah, one
Sir, from
person.
0.
Yeah, Kaushal.
From 0, sir, we went to 1 instead of going to 4. We know, sir, that we need to go to small node, but how do code know that?
From 0 we went
how
to.
can code understand that?
Same
1, sir, instead of going to
Yeah,
4.
so that is what Sapna asked and I explained her. See, look at this code. I mean, forget about where we are right now. How this for each j in columns of A, what columns of A returns?
Yes,
Columns of A returns a list which contains values from 0 to 6, 0, 1, 2, 3, 4, 5, 6. So value of j will always be 0 1, 2, 3, 4, and so on. For every procedure call, J will always start from 0 and it will go till 6 until you stop it in between. But J will always start from 0. And that is why every time we will compare, let's say I will have some value, right? I will have some value, ij, that is that I0, I1, I2, I3, I4, I5. That's what we will do. And in that particular order, as you said, there is 1 and 4. 0, 1 will come first. And when 0, 1 comes, we will do this procedure call. And because of that, 0, 4 will not even get checked at that point of time. Because we know whenever there is a procedure call, we will do this procedure call again, and this J will again start from 0. Previous one will get forgotten.
Yes, sir. Got it, sir.
Got it?
Yes, sir.
Yes. Yeah, Praveen, you have raised your hand. What's your doubt?
Yes, this is a question regarding graded assignment 11th deadline. Is it on 23rd March?
Yes, week 10 and week 11, both deadlines are on 23rd.
So is there going to be a week 12 also?
Yeah, week 12 is there, but week 12 will not have graded assignment.
Okay, so there will be only 11 graded assignments for CT.
Yes, only 11 graded assignments are there in CT. Week 2, I mean, for CT, okay, for other courses, I don't know. But for computational thinking, we have only 11 graded assignment. Week 12 is just summary lecture. So in week 12, I have recorded some four lectures I have recorded, 4 tutorials I have recorded, where all weeks from 1 to 9, 1 to 10, 1 to 11, whatever is there. I mean, all those weeks are combined together and prepared some small summaries of entire computational thinking.
Okay, it's kind of a revision week.
Yes, it's a revision. I mean, that is something which will help you prepare for end-term exam.
Yeah, because there are a lot of assignments already from now to 25th. So I was wondering if there is another graded assignment also to solve.
No, yes. Yeah, we understand that. That's why week 12 is not there. Actually, week 10 deadline was previous Wednesday. I mean, as per the schedule, right?
Yeah, it has already been postponed, yes.
Yeah, it is postponed, and that's why we kept 10 and 11 together, because 12 is not coming. So you don't have to study something new for 12. You don't have that. That's why 10 and 11 is together, 23rd. And the reason is 3rd is your exam, right?
Yes.
And we also need some time to process your scores, generate your hall tickets, and do all that procedure before that.
Yes, so could you change the dates at least just by at least 1 or 2 days so that
that's not going to happen. 23rd is the date for both, and it's not going to happen no matter what we do.
It's going to be very tough.
So let me tell you, to be honest, it's not even in my control. It's operational call, and it's at that level where Bharti ma'am is very. You know Bharti ma'am, right? No, I mean, she's the operational head of this entire program.
Yes, sir. She took initial starting
Yeah,
session.
she might have taken, I mean, she doesn't take sessions, but she might have done some orientation at the beginning or something. But yeah, she's the operational head, and she's very particular and very strict about these deadlines when it comes to operational aspects. So this is not going to change no matter what. 23rd is the deadline for week 10 and 11. And it's not just for CT. If you look at across any course, you will not see any deadline beyond that, because the team needs some time to process everything. Then only exam can be conducted on 3rd of April.
So because from now till till 25th, there are around 12 assignments to be submitted. So it's on average 1 assignment per day.
The thing is, you shouldn't have taken 4 courses. Let me go back there and say that you shouldn't have taken 4 courses.
Yeah.
That's why I took only 2.
This is the foundation course, right? So this is the first time. So we are learning hard lessons the wrong way.
I hope you will learn from this and take a right call in next term.
Yeah, it could be possible if we do not have any backlogs, but I have some things to clear up from a couple of subjects, so that makes it extra difficult.
Correct. And I mean, that's what, right? Based on your own availability, you should take this call.
Yeah. Okay, thank you.
Thank you.
Okay, thank you everyone. We'll close the session.
Last question.
Yeah, Ramakant, go on.
Sir, actually, जो summary videos you told ना you have already prepared.
Yes.
So that is already available now. We will be uploading later.
Okay, week 12 is not yet released, right? Let me quickly check.
No, sir, it's not there, right?
No, it's not, right? It is. I think it is supposed to come on this Friday. Yeah, this will come. It will come on this Friday.
So that will cover from week 1 to week 12 all the summary videos.
Yes, it will have all summary of computational thinking. The week 12 will be released on this Friday, which is 18th, another 2-3 days.
Okay. Thank you.
Okay, yeah. So you will get enough time to go through.
Okay.
Okay.
Yeah. Sir, you will upload this peer deck slides right now?
Yeah. I mean, in next hour or so.
Okay.
In some time you will get it on portal. I mean, it will come.
Okay, sir.
Okay.
Thank you so much, sir.
All right. Thank you, everyone. Bye bye, everyone.